This video is about O3, its benchmarks. Is it AGI or did they cheat? What's the reality of the situation? So on the last day of shipments, OpenAI announced their O3 model and some of the benchmarks that they've gotten. We haven't had a chance to actually test it yet, but this is the one that I think gets has gotten a lot of people really excited, and some people even claiming AGI is here. So there's an Arc AGI benchmark where about a year ago the highest model got in the single digits percentage points. The latest, the best, most recent score before this was, I believe it was Claude 3.5 Sonnet, which got a smidge less than 50%. So going to 87.5% seems pretty amazing. Let's ignore the fact that we don't really have numbers here, and we'll actually kind of circle back around to that. So what does this really mean? And then there's some rumors about kind of them cheating. I think it's a little bit misleading to say that they cheated, and I'll go into the details there, and we'll look at what does it really mean? What do these benchmarks really mean? And I shot a separate video on what benchmarks really mean, and I'm going to approach it from a bit of a different angle with more context on this one. I think digging into how they actually built O3, what happened with O1, I think this is going to bring a lot of clarity. Again, what the benchmarks really mean. Did they cheat? Is this a wall? And is this really AGI? So let's dig right into it. So how did they build O3? So they did. It's very similar to what they did with O1. At least this is what they're claiming. Basically, what they did with O1 was they had it generate the O4O generate potential solutions, and then they fine-tuned. They had reinforcement learning where humans marked it up, and they fine-tuned on the better answers. So essentially, what they were doing there is narrowing down the scope of the model's responses to the better reasoning in its data set. All right, and they took that, and then on top of that, they add chain of thought compute, which actually turns O3 into not just a model. There is an O3 model, but it is also a process, which it seems like there's a distinct lack of distinction between those two things, and how important that is in the general discourse, because O3 is not just a model, and that way you can't really compare it to some of the other previous benchmarks. It's comparing two different things. Now I think this is really important to go in that direction, of not just thinking about these in terms of models, but in the past with 4.0 it was basically an in out. You had the model, you gave it an input, and then it gave its one response. While O1 and O3 has the chain of thought, where it actually it's a process and a model. Now it's a very simple process. Now maybe they're doing some advanced things, and we don't have a full open source of it, but in general I think we have the main idea of what they're doing, which is chain of thought, which is 2-year-old technology. So it's not really that complicated, but they're essentially putting the model in a loop. So they fine-tuned it on more reasoning that's already in its data set with some human feedback. So they narrowed it to the better and better reasoning. So with O3, I think they got even closer to the better parts of the reasoning data set, and potentially the better parts of the reasoning data set that are more relevant to this. Depending on how they might have, there's some indications that maybe they targeted it to some degree, or at least they were trying to optimize for that benchmark, because it's good for them. And it's just they're incentivized to optimize for this because it makes them look good, and a lot of people are real excited about this, and they think that they have AGI, which we'll talk about in a second. So I want to so many people, when they first see these things, they get super excited. Oh my God! That again, they going from the 50% being the highest to 37.5% is an achievement for sure. But what happened with O1 was people got really excited, and then as we got a chance to use it and play with it and put it into the real world, a lot of that excitement died down, because we realized that what they showed us was it's the best angle. It's the MySpace angles of benchmarks for models, where they show us the best things that it does, and then they ignore the things that it actually didn't do better, or that actually did worse. And in terms of actual real-world practical use cases, O1 was not a massive improvement over 4.0, in my opinion, based upon the data. Again, there are some use cases, but in general, a lot of the times it just was. 4.0 did just as good as O1 in a very large amount of the use cases. And I think what they're doing is it's improving for very specific use cases, and they're showing the use cases that it ends up working the best for. So let's dig into the benchmarks. This is actually really funny. This is exactly, this is kind of what they're doing. A misleading benchmark test can accomplish in minutes what years of good engineering can never do. So that is incredibly true, and that is pretty much what is happening to some degree. I'm not saying they're lying, but there is a ton of caveats to these benchmarks that I think are really important to consider and think about before you declare this AGI. So first of all, it's good that they're improving in math. These are language models, so the fact that they don't do math very well is not incredibly surprising. But I don't really feel super great about this, just because of the way that they're trained, especially when it comes to science-oriented questions. You think, oh, well, this is like very logical, but actually a lot of these are just, it's just information. It's regurgitating knowledge to a very significant degree. To some extent, I think in math, although I'm happy to see this, and I'm less concerned about, oh, is there going to be, and it's possible that what they're doing is they're kind of plugging in different resources to get the math right. I don't think we really know exactly how they're doing the math. This is nice, but again, it depends on a lot of different factors, and this is a very narrow scope of math, a very narrow slice of science. So this is cool. When they talked about, that there's this clip going around of somebody, some very advanced math person saying that these are very, very hard problems to get. But again, I think that so far there's no indication that this isn't just them doing a better job of narrowing the scope of their training set, and that the basics of these math problems, the foundational pieces of them, are in their training set. And so that allows them to do that. And to actually logic their way. And again, in general, the reasoning, that's not to say that it's bad. That's not to say that they completely cheated and there isn't value to this. So benchmarks do mean something. I don't think they are nearly as meaningful as what people want them to believe. Here's one of the ones that they're really, pimping out there, was the SWE bench with software engineering verified. So the current highest score, I don't know if O1 was verified, but I think it was, because I didn't see it on SWE's official website. It was an Amazon one that was right around this level. I think it was a smidge less than 50%. And so for them to jump 20% is good. But, you really have to consider what exactly is this? And this is like fixing bugs. This is not really coding new things. This is going on to GitHub and fixing bugs, which is not the same thing as all coding and all potential scenarios. It's very nice and impressive, and this is going to be useful, I think. But again, this doesn't mean that it's going to start coding itself and improving on itself. There's no indication of that yet, and it might still be a long time. Maybe we're around the corner there. So again, coding competition, and these are like really impressive scores. So to be clear, I think that they were talking about how even like really top tier coders often don't get this level of a score. So that's really good. Again, the models themselves have major advantages, and this is getting better at finding the more relevant things in the data set. I think that generally what is happening here is they're narrowing the scope of the data set. So instead of it sometimes doing the crappy parts of the data set, it finds the better and better parts of its data set. And it's not that it's able to do new things, it's just more reliably getting the right answer with its next tokens. And so I already mentioned this. Let's also take a step back from the fact that the Arc AGI Benchmark has AGI in its name, but that does not mean that that getting a really good score on it means it's AGI. Absolutely not. It is meant to measure an aspect of models that is challenging, that is, I think I heard somebody else put it a really good way, which is it's a necessary but not sufficient ingredient. So yes, I think that not being able to score well on this means that it's not AGI. But it's one of many pieces of the puzzle. But scoring really well on it does not mean it's AGI. And we'll talk about kind of like, let's take a step back and look at what the definition of AGI is in a second, but we'll circle back around that as we get to the conclusion. So $350,000 on compute. So if you go up to the top, this is a rough estimate. They spent $350,000 on compute to get this result. Okay, I want you to really think about that. That's how hard they had to work on it. And if they were willing to spend that much money to get the benchmark, how much money did they spend engineering for that? Okay, so they're kind of, this is not necessarily training on the model, it's on the benchmark itself, but it is clearly this was really important to them. Why else would they spend $350,000 on it? And if they spent that amount of money, how much did they spend on engineering and focusing on actually trying to be like, hey, this is important for the future of the company, for our ability to get funding, for our ability to make sales, to get a really good benchmark. I mean, it's a valid strategy, but this is what all these benchmarks are incentivizing companies to do. They're incentivizing them to optimize for the benchmarks and not actually necessarily what the real world uses are. So did they cheat? So something to be clear about, which is that the Arc AGI benchmark has been in the public data since like 2019, 2020. So it's already been in the data set for all these models. And then I think they mentioned that they used about 75% of it. It's in the training set. That's basically what they said. So this is still impressive because all the other models didn't get this, or were not able to score well on this benchmark up until very recently. So in that sense, it's really really impressive. But it also kind of leads us to understand, when you understand how they built 01 and 03, how they got this, and it seems like the reasoning that allows you to do well on the Arc AGI benchmark, and by training on that and focusing the model's responses, its logical reasoning on that part of the data set, intentionally or unintentionally, just through the fine-tuning of it, getting those responses, the types of responses that would be better on Arc AGI, and then utilizing that part of the data set more frequently. Again, whether or not they actually went in and pointed at it, or whether or not it just kind of naturally happened through their fine-tuning of the 4.0 model, is not really, it's not really here nor there. I mean, it would be bad if they intentionally really focused on it too much. But which I suspect that they didn't do, but we have no indication one way or another. And I'm sure that to some extent, though, there's some amount of that's it's just a natural incentive for them to focus on it to some degree. So, but at the same time, this doesn't mean it's going outside of its training set and doing new things. And so in a sense, it's not really solving novel problems. And I wonder if they were to actually pull this out of the data set, remove all the fine tuning that they've put on top of it, start over with 4.0 without this in its data set, and then do the same process over and over again, if they would get the same result. My guess is that the answer would be no, depending on how many other problems in its data set are already kind of like Arc AGI, which I mentioned that there's some things like this, that there's on the internet kind of weird word problems and kind of logic problems somewhere out there in the internet that's in its training set that are similar. I don't know how many of those there are, but I'm guessing that there's some amount. So it's unclear if that would really change anything. But it doesn't mean that this is something that it has pulled out of nowhere. It's been in its training set, and the fine tuning has narrowed down its ability to focus on that. Okay, so I've heard some people say, "Oh, well, this shatters the wall." In my videos, hopefully you've seen, if you've seen them, I did not say that there was a wall, and I've said that there is a slowdown on the models themselves, which is very different. And then there's people are talking about, oh, well, this is an acceleration because since 01, only 3 months ago they were able to do this, and because this benchmark was, in the single digits, and now it's 87, that's clearly like super speed. Again, I think that's a bit misleading. You're thinking very linearly instead of non-linearly. You're putting too much meaning onto the benchmarks. AI in general I don't think has hit a wall. I do think that the models themselves have slowed down since GPT-4, and that continues to be true, even with O3. Okay, so just really think about the distinction there. They are improving on how they use the models, which is something that we've focused on in our company for the last 2 years. And I think that is where the industry needs to go much more aggressively. So that's good that they're doing that, even though they're just dipping their toes in that area, and they're still very model focused. But the models themselves have not really improved here. That's why they didn't go to GPT-5, because the LLM itself, and again, O3 and O1 are not just models. This is so important that I've not heard anybody else talk about. And you know, let's compare so that this is significantly slowed down. I still think there will be improvements, but it won't be at the GPT-2 to GPT-3 level and stuff like that. AI more broadly, so there's a lot of things outside of LLMs, or kind of, let's say, more like AI adjacent, that are improving significantly because so much of the focus has been on the models themselves, and so little of the focus has been on how do we leverage them as tools. And as people look at that, I think there's a lot of room to work in that area. And to be honest, processes are the way. And by processes, I mean putting the LLMs within a more complicated process than just chain of thought. There is so much room to grow there. So in that way, I wouldn't say AI has hit a wall, and I think there's a lot of room to potentially even to accelerate or to keep some sort of significant pace of improvement in AI with that angle. But the models themselves have slowed down significantly in their progress, and that has not changed even with this amazing result, because of the way that they've done the process is where they've gotten all the results. Okay, so conclusions. Is O3 AGI? Let's see. Hopefully by now you can probably tell my answer is generally no, but let's first take a step back and let's look at an LLM's actual definition of AI itself, of AGI itself. So I'm using O1, and this is to try to not move the goalposts too much here, because I think that there's goalposts moving in both directions. And I think I heard somebody call it a jagged AI, AGI, where it's good in some areas and not good in others, which is kind of like an oxymoronic, to be honest, because it's supposed to be a general intelligence. So it refers to a theoretical class of artificial intelligence that possesses human level or beyond human level across a broad range of tasks. Unlike narrow AI systems, which excel at single or limited tasks, an AGI would be able to understand, learn, and apply knowledge in virtually any domain. Such as a system would exhibit general problem-solving abilities, adaptability, creativity, self-awareness, and the capacity for continuous self-improvement. Okay, so this is 100% not satisfied. So I think by this statement in and of itself, this is not AGI. Just by this thing right here, it is not shown. I don't care what it shows on the SWE and any other coding benchmarks. It has not shown this. The LLMs or the LLM put in a process, put in a system, has not shown an ability to improve itself yet. Okay, not even a little bit. Humans have had trouble doing this. So and the models themselves have definitely not been able to do that. And I think there's several other pieces missing here, like adaptability. I think creativity is arguable because it can't create new ingredients, but it can create new recipes from the ingredients that are already in its training set, which is what is happening. Self-awareness. This is arguable, whether or not it's actually self-aware. In some sense it is, but it's also reasonable to suggest that its self-awareness is just mimicking human self-awareness that it has in its training set. And apply knowledge in virtually any domain. I think it's kind of close for this. It's unclear. I think that there's a lot of reason to suggest that it actually doesn't understand, and that it actually can't really learn in the, like, if you give it stuff, it doesn't actually learn it. That it's doing something not like learning and not like understanding. So I think it's still missing quite a few pieces of the puzzle here. One really important aspect of this is that it is a system, and it is not just a model. You cannot get AGI with just an LLM. So that's again why it's good that they're moving into a process or a system. And I think that the actual when and if we ever have AGI, it'll be a very complex system, just like our existence as humans is a very complex system. There's a lot of pieces to the puzzle to us to exist as a sentient being. that go beyond just regurgitating facts or remembering things. And so just remembering things, or even just having really good logic and reasoning, is not enough, not even close to enough for AGI, in my opinion. So, let's take an honest review of that. This is not AGI. I don't care if they've maxed out all the benchmarks. That does not mean it's AGI. There's more to it than that. And the benchmarks have a narrow slice of meaning of what's going on. So what would it take? Again, I think this is a pretty good definition of AGI. And to suggest that it is anywhere near all of this based upon a benchmark that has AGI in its name and a significant improvement there, which is impressive, and in coding, is not very reasonable. So I know it's exciting, and maybe there's a lot of people out there. I think it probably gets more clicks to be like, AGI is here, because AGI is very interesting, and it has been, and people have been saying we're really close to AGI since ChatGPT came out, and then it's going to accelerate. I think this is a nice step in the right direction, and I'm happy to see the process go beyond the model and focus on the model, but less on the model and more on other aspects of it, of using the model. And I think that's the right way to go. And there's a lot of work in that domain that needs to happen before we hit AGI. So let me know what you think. If you agree with this, please please like and subscribe. If you don't agree with it, please leave a comment on what you don't agree with, and happy to discuss any aspects of this, whether or not this is actually AGI. Did they cheat? Is there really a wall? Is it just a slowdown? Are they accelerating? What do you think of the Arc AGI benchmark? Let me know in the comments. I'd be happy to discuss with you, and have a great day. Thanks for watching. Bye.